Today our focus is on solving systems by substitution method. Use the substitution method to solve. Now we've been substituting for an awful long time. A few examples of how you substitute. If x equals 3, what is x plus 4? Well, you would take what the value of x is and you would plug it in to x. So 3 plus 4 would then equal 7. We're going to do the exact same process with equations. Notice that I have y all by itself in the same way that I had x all by itself. And y in this case is equal to this value, x minus 4. And since it's equal to that value, we're going to take that value and we're going to plug it in anywhere we see y. So let's rewrite our equation. 4x plus, I'm substituting in instead of y, now we're writing x minus 4. Now again, I want to see what's in front of the parentheses. It's a plus sign, so I don't need the parentheses anymore. 4x plus x minus 4 equals 26. So we'll combine our like terms. 5x minus 4 equals 26. We'll add 4 to both sides. 30 equals 5x. And we'll divide by 5. And so we finally realize that x has a value of 6. Well, once we know the x value, it's very easy to find the y value. Y is equal to x minus 4, and we just said that x was equal to 6. So we're going to plug that value in. Y equals 6 minus 4, so y must be 2. Now, it's generally a good idea to check your solutions, so let's work this. X is 6 minus 4 equals 2, but let's make sure it works for both equations. 4 times my x value plus my y value must equal 26. 4 times 6 is 24, plus 2 equals 26. Does it? 24 and 2 is 26. That equals 26. And so we've checked our solution and verified that it works. Our solution for this particular set of equations is 6, 2. That's the ordered pair that satisfies this system of equations. All right. Now, sometimes it's the case that it's easier to solve for your variable y. Sometimes it's the case that it's easier to solve for variable x. Notice this question, the question for this page only asks us to identify which it's easier to solve for. It doesn't tell us that we need to solve for the entire system of equations. So in this case, let's look and see what's easier to solve for. Well, 3 has a coefficient, y doesn't. It's going to be far easier for me to say 3x plus y equals 8, subtract 3x from both sides, and y is equal to negative 3x plus 8. Notice I have a variable isolated and all by itself. We can take that value of y, and now we can plug that in for y. All right, next problem. 4x minus 5y equals 11. Well, what's going to be easier to solve for? Here I would probably argue it's going to be easier to solve for x. That's one step. X minus y equals 6. So I'm going to add y to both sides, and x equals y plus 6. In this case, we have x equaling a particular value. We want to identify what it equals, and then we're going to plug that in so that we can solve the system of equations. Last example, 4x minus 5y equals 11. 3x minus y equals 9. Here I would probably say your simpler process is again to isolate the y. So 3x minus y equals 9. Subtract 3x from both sides. Negative y is equal to, negative 3x plus 9. Where we'll divide by negative 1 on both sides. And y is now equal to 3x minus 9. And since we now know the y value, we can take that y value and plug it in to solve the system of equations. So let's try this again. I'm going to ask you to pause the video here, give this one a shot, and then come back and see how it was done. All right, welcome back. So which variable did you solve for? In this case, it's pretty easy to solve for x or y. I generally like to use y just out of habit. So I'm going to say x plus y equals negative 2, and I will subtract x from both sides. So y is equal to negative x minus 2. Now, I'm in a habit of boxing what I'm going to substitute. So I'm going to substitute the value of y into my second equation for y. So 2x minus 3. My y value is negative x minus 2 equals negative 9. Now I have parentheses, so I want to look in front to see what it is. Notice this is a negative 3 in front of the parentheses. So we want to distribute that negative 3 before we do anything. So let's drop down the 2x. Negative 3 times negative x is going to give us a positive 3x. Negative 3 times negative 2 is going to give us a positive 6 equals negative 9. Well, now we're just solving a two-step equation. 2x and 3x is 5x plus 6 equals negative 9. We subtract 6 from both sides. So 5x equals negative 15. And we divide 5 from both sides so that x is equal to negative 3. All right. We just did a lot of work to figure out the value of x. Where should we plug it back in to find y? You can plug it into either equation, but I'm going to suggest you use the easy one. Negative 3, which is my value of x, plus y equals negative 2. So we add 3 to both sides, and y is equal to 1. My ordered pair, negative 3, comma 1, is my solution. Again, please make sure you're in the habit of checking your solutions. So we have 2x minus 3y equals negative 9. It's easy to check solution in the first equation. 1 plus negative 3 is negative 2, negative 3 plus 1 is negative 2. But now let's check it in the more complex equation. 2 times negative 3 minus 3 times 1 equals negative 9. 2 times negative 3 is negative 6 minus 3 equals negative 9. Negative 6 minus 3 is negative 9, which does equal negative 9, so we did good. Solve by substitution. Again, pause the video, give the problem a try. All right, here we go. Let's see if you got your answer right. Negative 3x minus y equals negative 9. I'm probably going to solve for y because it does not have a coefficient in front of it, which means it will be the simplest, easiest one to solve for. So in this case, I'm just going to go ahead and move y. You'll see why in just a second. Negative 3y equals y minus 9. Add 9 to both sides. Negative 3y plus 9 equals y. And notice I have simplified the equation. just as I would have if I had subtracted 3x and then divided by a negative, but this kept me from having to divide by a negative. So now my y value that I'm using is negative 3y, negative 3x, sorry, let's clean that up, negative 3x plus 9 that equals y. So we're going to plug in our y value anywhere we see y in the second equation. So negative 4x plus 2 times negative 3x plus 9. We need to distribute. So we have 2 times negative 3 is negative 6x. 2 times 9 is 18 equals 8. Negative 4 and negative 6, that's negative 10x plus 18 equals 8. We'll subtract 18 from both sides. Negative 10x is equal to negative 10. Divide by negative 10 on both sides. X is equal to 1. All right, you can plug that into either equation. It looks like it's going to be easier to plug it into our first one. Negative 3x minus y equals negative 9. So we have negative 3 times 1 minus y equals negative 9. Negative 3 minus y equals negative 9. Add 3 to both sides. Negative y is equal to negative 6. We're going to divide by negative 1, and of course that will make both sides their opposites. So my y value is positive 6. So we have a solution of 1, 6. Can we check that to make sure it works? Negative 3 times 1 minus 6 equals negative 9. Negative 3 minus 6 equals negative 9. Negative 9 equals negative 9. It worked for that equation. Negative 4 times 1 plus 2 times 6 equals 8. Negative 4 times 1 is negative 4 plus 2 times 6 is 12 equals 8. Negative 4 plus 12, that is 8, does in fact equal 8, and we're good to go. All right, one more for you to try on your own. All right, in this particular problem, I see 2y, I see 0. Chances are when I move something over, that's going to get rid of the zeros. That's going to make that one a little bit simpler to solve. 6x minus 2y equals 0, minus 6x from both sides. So negative 2y equals negative 6x, where we'll divide by negative 2. And y is now equal to 3. All right, since y is equal to 3x, we can now take that 3x that we just said y is equal to, and we can plug it in to my other equation anywhere I see y. 2x minus 4 times whatever we just said y was, 3x, equals negative 50. So 2x minus 4 times 3 is 12x. Equals negative 50. 2x minus 12x. Well, that's going to give me negative 10x equals negative 50. Divide by negative 10 on both sides. X is equal to 5. So let's plug 5 into one of my equations. Doesn't matter which one. 2 times 5 minus 4y equals negative 50. 2 times 5 is 10, minus 4y equals negative 50. So we want to subtract 10 from both sides. Negative 4y is equal to negative 60. Divide by negative 4. And y is now equal to 15. So our solution, 5, 15. Can we check that? Yes, we can. 2 times 5 minus 4 times 15 equals negative 50. 2 times 5 is 10 minus 60 equals negative 50. Negative 50 does equal negative 50, and so we're good with that one. 6 times 5 minus 2 times 15 equals 0. 6 times 5 is 30. Minus 2 times 15 is 30 equals 0. 0 does equal 0, so we're good with that one. That solution does satisfy both equations. Now let's look at some application. The sum of two numbers is 27. One number is 3 more than the other. What are the two numbers? And before we can do anything, we've got to figure this mess out. Try to put some equation behind all of these words. So the sum means that I'm adding two numbers is 27. Well, if I have two numbers and we're not told what they are, they could be the same, x and x, but not likely. So probably an x and a y. Well, that would be a first equation. X plus y equals 27. All right, now we get a little bit more information. One number is 3 more than the other number. So it didn't really matter which. We just know that one number is 3 more than the other number. So if I take a number and I add 3 to it, that's going to be equal to the second number. Well, that's another equation. X plus 3 equals y. Now here we already have y by itself, so it makes sense for us to box that and plug it in. So we will have x plus the value of y, which we said was x plus 3, equals 27. And again, I want to look in front of the parentheses. There is no subtraction sign or negative sign. And so we can get rid of the parentheses. X plus 3 equals 27. So x plus x is 2x plus 3 equals 27. And we'll subtract 3. So 24 is equal to 2x. We'll divide by 2. And x is equal to 12. Now again, it doesn't matter which equation we plug this into. 12 plus y is equal to 27. So we subtract 12. And we get a y value. 7 minus 2 is 5. 2 minus 1 is 1 of 15. So our solution. Well, here we're not looking for a solution that's really an xy ordered pair. We're not graphing this. We're talking about one number and another number. So our solution is our first number is 12. Our second number is 15. Now we do probably want to check our answer just to make sure it worked out. So let's take our first equation, x plus y equals 27. 12 plus 15 equals 27. 12 and 15, yeah, that's 27 equals 27. We're good. Let's check it in the next one. X plus 3 equals y. Well, we said our x value was 12, so 12 plus 3 equals 15. 12 plus 3 is 15, which does equal 15. So again, we're good on both of those equations, which means our solution is correct. The perimeter of a rectangle is 48 inches. The width of the rectangle is 2 more than half of the length. Find the length and width. All right, let's start with this perimeter. That means I added all 4 sides. Or, remember something about perimeter. We have a width, we have a length, we have a width, and we have a length. Oops, sorry. We have a length and a width. So we have 2 lengths and we have 2 widths. 2 lengths and 2 widths. Added them all together and that gives us 48. Well, that looks like an equation there, doesn't it? So let's make that our first equation. 2L plus 2W equals 48. We've used our first sentence. The width of the rectangle. So the W is, which is generally a good indicator that you're using equals, 2 more than half the length. All right. So if we have half of the length and it's 2 more than that, well, that looks like another equation. And the nice thing about this particular equation, it's already isolated a variable. So we can take our right side and plug it in. Now, so we are told 2L plus 2 times the width, which we just determined was going to be this value right here. 1/2 plus 2 equals 48. Now let's distribute first. So 2L plus 2 times 1/2 is 1. Sorry, 2 times 1L over 2. 2 times 1/2 is 1L. 2 times 2 is 4 equals 48. Subtract 4 from both sides, and 44 is equal to 2L plus L. All right. So we're left with 44 divided by 3. Well, it's not a very friendly number, but it is an improper form and it is simplified, so I'm fine with that. Let's now find our width. All right, so we can plug this into either equation. Let's go ahead and use the one on the top. 2 times 44 over 3 plus 2W is equal to 48. That's going to give us 88 over 3. That's not going to be very friendly. 2W is equal to 48. Remember we talked yesterday about clearing, or earlier this week about clearing fractions? So let's go ahead and do that. 3 over 3 gives us 1 times 88 gives us 88. 3 times 2 is plus 6W equals 48 times 3, which equals 144. That's going to be a little bit easier to clean up. So subtract 88 and that gives us 56. So we want to divide by 6. And W equals 56 over 6, which can simplify to 28 over 3. Now the question of the day, will these add up to the correct 48 inches? So remember, we need a length, 44 over 3, plus 44 over 3, plus a width, 28 over 3, plus 28 over 3. And we want that to all equal 48 inches. So let's do a little math. 44 plus 28 plus 28 gives me 144 over 3. All we did was add these 4 fractions together. Equals 48. Let's simplify. 144 divided by 3. 48 equals 48. We did all of the fraction work beautifully. Now, I'm a big fan of clearing out fractions. It makes things a lot easier. We don't have to worry about did I subtract, add, multiply, divide all of these fractions correctly. So we want the length. Length is equal to 44 thirds inches. The width is equal to 28 thirds inches. And we call it a day.